Hello and welcome to this first video where we are going to learn about accuracy and precision. Now, chemistry is the study of matter and how matter reacts with other matter, but before we get into those things, we need to build a baseline of information that we're going to use for the entire year. So these first couple videos are going to be talking about measurements and how to take proper measurements. And the first thing we're going to talk about is the difference between accuracy and precision. Now, if you look at the screen right here, we've got two different types of measurement. We have a beaker and a graduated cylinder, both measure volume. Then we have two scales, both measure mass. And so we're going to talk about how those different pieces of equipment to measure volume and mass, how one might be more accurate or precise than the other. So let's talk about what accuracy is. Accuracy is how close a measurement is to the true value. Now, when you take, for example, the mass of something, a scale might or might not be accurate. And that all depends on if it's been calibrated correctly, but the point is that if something is 5 grams and you go and weigh it and it says it's 6 grams, that's not accurate. Now, precision is how close a set of measurements are to each other. And we're going to look at an example of this in a moment. But precision is how close a set of measurements are to each other. Now, we're going to take a look at an example of this in a moment, but essentially if you take a set of measurements, for example, let's say we take our 5 gram mass and we measure it multiple times, if all of the measurements say 6 grams, those measurements are precise because they're very close to each other. Now, even though it's not accurate because it's 5 grams, the fact that they all say 6 implies that it's precise. Now, another way of thinking about it is, let's say we take a bunch of measurements and one measurement says 5, one measurement says 7, one measurement says 4. Those are all pretty different from each other, and so that would not be precise. So let's go ahead and take a look at some examples of what that is. Now, if you take a look at the screen here and at the document that is in your booklet, you will see that there's 4 different targets. And so what you can do is you can mark where the darts are on each target. And so on the first target, you'll see that each dart is actually in the bullseye. So they're very close together. So the first thing we're going to do is say, because they're in the bullseye, they're said to be accurate. Not only that, because they're tightly grouped together, they're said to be precise. So this is an example of high precision and high accuracy. Now, if you take a look at the next one here, you'll see that the darts are not at the bullseye. They're actually off to the side. And so this is not accurate. But they are grouped together. So we will say that is precise. So even though it's low accuracy, it is high precision. Now, this next one here, if you take a look, the darts are kind of spread out and they aren't really grouped together, so it's not precise, and they're not really close to the bullseye, so it's not accurate either. So this last one here is a little bit harder to see, but I think for precision we can see that it's not precise because they're spread out, they're not grouped together, so it's not precise. However, what about accuracy? Is this considered accurate? Well, if you take the average location of the dart, you'll see the average is actually right where the bullseye is. So that actually is going to be accurate. So this is going to be low precision, but high accuracy. Now let's go ahead and take a look at these two scales here. These two scales are actually different. If you look at the one on the left, it will measure to 2 decimal points. The one on the right measures to 3 decimal points. Because the one on the right measures to 3 decimal points, we'll say that that scale is more precise in measuring mass. So now let's go ahead and take a look at the beaker and the graduated cylinder. You'll see the beaker, each line counts by 10, and the graduated cylinder, which is on the right, each line counts by 1. Because the graduated cylinder has lines that count by 1 versus the beaker which counts by 10, the graduated cylinder is said to be more precise. It can take a more precise measurement of the volume of a particular liquid. Okay, so let's go ahead and talk about percent error. Because sometimes when you take a measurement with something, there's going to be some amount of error involved in that measurement. Now, the percent error is calculated by subtracting the experimental value from the accepted value and then dividing by the accepted value multiplied by 100. And we're going to go ahead and take a look at the formula here. If you take a look, it is the accepted value, which is the true value, minus the experimental value, which is always going to be the value that you measure. So anytime you take a measurement, that's going to be your experimental value. And then you divide it by the accepted value multiplied by 100. If percent error has a positive value, what that means is that the accepted value is larger than the experimental value. And we're going to see an example of why that is in a moment, and I think it'll make sense. Now, we're going to go ahead and calculate the percent error of an experimental mass of 5 grams when the accepted value is 10. And so if you take a look, the known is the experimental value is 5, the accepted is 10, and so let's go ahead and calculate the percent error. If you take a look, we got our equation here on the top, accepted minus experimental divided by accepted times 100. That's a mouthful there. And if you take the 10 and you subtract the 5 and then you divide it by the 10 multiplied by 100, you get 50%. Now notice it's positive. It's positive because the experimental value is less than the accepted value. Now let's go ahead and talk about what happens if you get a percent error that is negative. So a negative percent error is the opposite, obviously, of a positive percent error. What it means is the experimental value is actually larger than the accepted value. And again, we're going to go ahead and take a look at an example of how that works. And so in this example here, we're going to calculate the percent error in a length that is 10 centimeters. However, the accepted value is 5 centimeters. So the experimental value is 10 centimeters, the accepted is 5. And so let's go ahead and take a look at what that calculation looks like. So again, we've got our equation at the top. We plug in the what we know, and we end up getting a negative percent. So it's a negative 100%. And so should the answer be negative? Well, yes, because if you take a look, the experimental value, which is the 10 centimeters, is larger than the accepted value. All right, and that's all you need to know about accuracy and precision. Now, before I finish this, let's go ahead and look at this last image here. We've got 3 sets of measurements. Now, what we're going to do is we're going to define exactly what we're going to call accurate. We're going to call something accurate if it's within 0.1 of the accepted value. And we're going to call something precise if all of the measurements are within 0.2 of each other. And so let's go ahead and take a look at this example here. In student 1, you can see that, first of all, it's not precise. The 9.79 compared to the 10.49 is more than 0.2 away from each other. The other thing too is the average is more than 0.1, so we're going to say that it's inaccurate and it's not precise as well. Now for student B, if you take a look, the measurements are all really close to each other. They're really close to each other. So what that tells us is that it's precise. However, the average is more than 0.1, which means that is more than 0.1 away from the true value, which means that it's not accurate. Now, if you look at the last student is precise because all the measurements are very close to each other, and it's accurate because it's close to the true value. And that's it. That's all you need to know about accuracy and precision. I'll see you in the next video.